In this episode, we're going to investigate network address translation operations. I'll show you what we're doing and we'll talk about it along the way. As frames travel across the network, the MAC addresses may change. IP addresses can also change when a packet is forwarded by a device configured with NAT. We'll be investigating what happens to IP addresses during the NAT process. We will also be investigating NAT operation across the intranet and investigating it across the internet. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Labs 6.2.7 Investigate Network Address Translation Operations. I have our Packet Tracer Lab open up. On the left side, I have our work area where we have all our devices. We can go in and do our configurations and look at settings. On the right side, I have the instructions. On the very bottom right, I have the Packet Tracer activity window that opens up when Packet Tracer opens up. And then on the right, the majority of the right side, I have the Word document of those same instructions. The reason I have the Word document is we have some questions to answer. This will allow me to type my answers in and save them. Here we have our network. We can see we have a fairly complex network. We have kind of three locations. We have our central office right here. We have the branch office that's on the bottom right. And then at the top, we have a home office. Connecting there, we have some networks. In the center, we have the internet. And then sort of in the bottom center, we have the intranet. Here we have our addressing table. And we only have a couple devices here because those are the devices we're concerned with when we're going to look here at network address translation. Okay, down to our instructions. Part 1, investigate network address translation operations across the intranet. Part 1, step 1, wait for the network to converge. What we're waiting for is all of these green triangles to appear. Now, if it's not a green triangle, it's going to be an amber or orange circle, and you need to wait for those connections to turn to a green triangle. Now, if you're impatient, you could hit the fast forward button down here. This will fast forward at 30 seconds. And if you click it a couple times, you should get all of your green triangles. Once you have green triangles, we can go on to step 2. Step 2, generate an HTTP request from any PC in the central domain. First step we have to do is switch to simulation mode. Simulation mode is going to allow us to see step by step as the PDU travels across the network. As it goes to each device, we can then look at the information in it. Particularly, we can look at the IP addresses to see how NAT is working. So to change to simulation mode, right here, there's two buttons, sort of in the bottom middle of my screen right here. There's real time and simulation. By default, we're in real time, but we want simulation mode. So when I mouse over it, you notice it turns white. If I click on it, it will stay white, but then it also opens up this simulation panel here in the center. This will allow us to inspect the PDUs at any point in its journey. Okay, now we're in simulation mode. We can go ahead and open up the web browser on any PC in the central domain. The central domain, once again, is the bottom left domain right here, and the PCs are in the bottom of that. PC 1, 2, 3, and 4. I'm going to go ahead and click on PC 1. And I'll make that window a little bit bigger going right to left. That'll expose the web browser app here. Go ahead and click on the web browser app. In our app, we can go ahead and type in branch server.pka and click go. Then once we click go, we go ahead and minimize the browser window. So I'm just going to go ahead and minimize it. Don't close it. If you closed it, open it up and do it again. Just minimize it. Now, click the capture forward button until the PDU is over D1 or D2. D1 or D2 is right here. These are our distribution switches. So we got to click the forward capture button. Forward capture button only appears when you're in simulation mode, so make sure we're in simulation mode. But down here, it sort of looks like a triangle pointing to the right to a line. This is the forward capture button. Go ahead, if you click on it once, notice we now have a PDU. It's an envelope that appeared on PC1. Mine happens to be a purple envelope. Yours could be a different color. And we have to click this capture forward button until this PDU is up on D1 or D2. So I'm going to click it a second time. Notice the PDU moves from PC1 to the switch. Then I'm going to click forward capture. It's going to move from the switch to, or it's going to move from switch 1 to D1. Now you may have to click it a couple extra times. I only had to click it a couple of times, but you may have to click it 3 or 4 extra times. It may have to do an ARP lookup, or however the network is where you catch the timing. Once you get your PDU on D1, instructions say click on the most recent PDU in the event list. Here in this simulation panel, this is the event list, and they want the most recent one. The most recent one is down here on the bottom. This is the PDU, and how you know it's the correct one is there's this column that says at device. And so the PDU is at this device, it's at D1. That's where we are. That's what the instructions want us to do. Now, record the source and destination of that. So we got to click on this last one here. I clicked on it, it brought open this window. Now, record the source and destination IP address. Okay, let's go ahead and do that. If we look here in this PDU information window here for device 1, we can see some information. These are the inbound layers. So when the PDU is coming in, this is what our layers look like. When the PDU is going out, this is what the layers look like. And so we want to record the source and destination IP address. Right here, layer 3 is our IP address, and our source IP address is 10.2.0.4. And so we're going to record those addresses. Our source is 10.2.0.4, and then our destination is 64.100.200.1. 64.100.200.1. Then we have a question. To what devices do those addresses belong to? So 10.2.0.4 and 64.100.200.1. So what devices do they belong to? Let's scroll up to our addressing table, see if we can get some information there. And so once again, our source address, and I kept the PDU information window open, 10.2.0.4. Well, that was the source. That's where it came from. That's actually the IP address of PC1. But then we have the 64.100.200.1. If we look at our addressing table, 64.100.200.1, that belongs to R4. And so those addresses, so the source belongs to PC1 and destination belongs to R4. Now, if you did a different PC, you're going to have a different source address. It's going to belong to a different PC, but it'll still be in that same ballpark. It'll at least be a 10 dot number, and it'll be PC 1 through 4. Okay, on to step 2D. Click the capture forward button until the PDU is over R2. So I'm going to go ahead, close this PDU information window, and I'm going to click the capture forward button until the PDU is over R2. R2 is right here. It's one step away from our distribution 1 switch. So I'm going to go down here, click the forward capture button once, and it's on R2. Once again, you may have to click it a couple more times, but you have to get it on top of R2. Once it's on R2, we're going to go ahead and record the source and destination IP address of the outbound packet. And so we come over here to our event list. We're going to click on the last one. and we want the outbound packet. And so what we need to do is click on this outbound PDU details, or look at the outbound layers here. Either way, I'm going to look at the outbound PDU details, and what we can do is we can scroll down here. And as we look here, we can see that we have frame relay, which is configured there. Then we have our IP, which is our layer 3 protocol. Then we have TCP here, which is our layer 4 protocol. And then we have our upper layers, our HTTP request. If we look at our IP and we look at the actual frames, we can see that the source IP address is 64.100.100.3. Okay, so the source is, once again, 64.100.100.3. Destination, that's the next field down here. Destination is 64.100.200.1. So 64.100.200.1. What devices do those addresses belong to? Now notice our source and destination, our source no longer is PC1. Our source is now 64.100.100.3. If we scroll up to our addressing table, we look for 64.100.100.3. It's not in here. And so we're going to have to figure it out. Where is that IP address? 64.100.100.3. To find that IP address, I'm going to mouse over R3 here. I'm going to click in the window, mouse over R3, and see if it lists out my IP address. And here it doesn't list out 64.100.100.3. It is not assigned to any interface. So the source address is not assigned to an interface. And 64.100.200.1, well, that was up here, that was assigned to R4. And so the destination still belongs to R4. Destination belongs to R4. On to step E, log into R2 from the CLI using the password class to enter privilege exec mode. So here's R2. I'm going to go ahead and click on R2. I'm also going to close the PDU information window. Click back on R2. Click on the CLI. I make the window a little bit bigger going right to left. It lays out a little bit better. It doesn't do any weird wrapping. I'm going to log in, type enable. Then we have to enter in our passwords. We enter in class. And now let's go ahead and issue the show running config, and then show every line that includes the word pool. So we can do a show run, and then we're going to filter. You put the pipe sign in there, and we are going to include, use the keyword, and then every line that has the word pool. And you can see we have two lines that have it. One here, we set up a pool of addresses to use with our NAT. And then we set our NAT up and we tell it what pool to use. The address came from NAT pool R2. So the address that we couldn't find assigned to a device, it came from this pool right here. The pool called R2 pool. It was in this range. It happens to be the first one listed there. I'm going to go ahead and minimize the R2. On to step F. Click capture forward until the PDU is over R4. Now, right now we're over R2 here. We have to go till we're over R4. So I'm going to go ahead and click the capture forward button once. It's now in the intranet cloud. I click the forward capture button. It's now on R4. Record the source and destination IP address of the outbound packet. And so we have to look at the last one in our simulation panel. Once again, to confirm we're at the right one, we are at device R4. So go ahead and click on that. Opens up our PDU information at device 4. And we want to look at our outbound PDU. Scroll down until you find your IP address information. Here's our source IP address. Our source is 64.100.100.3, and our destination is, that's the next line down here, our destination is 72.16.0.3, or sorry, 172.16.0.3. Okay, it'd help if I actually clicked in the window. 172.16.0.3. What devices do those belong to? Now, once again, the 64.100.100.3, that belongs to R2, but that's the pool on R2. And so we have the source address belongs to R2 pool on R2. And then destination is now 172.16.0.3. Well, let's go up to our addressing table, see if we happen to see that. 172.16.0.3. 172.16.0.3. Not listed up there. Where is that? 172.16.0.3. I'm going to close the outbound PDU window. And I'm going to look here and see. Seeing as remember, we originally started with an HTTP request to the branch server. What I'm going to do is I'm going to click in this window. I'm going to mouse over the branch server. If we look here, the branch server's IP address, that's 172.16.0.3. That is the address that is the destination address when we're on R4. And so that is the web server IP address. Click the capture forward button until the PDU is over the branch server. The branch server is right here. So we got to move our PDU to there. So I'm going to click it once. Now we're on switch 4, click it capture and forward, and now we're on the branch server. Once again, you may have to click it a couple more times than I had to. Record the source and destination TCP port addresses of the outbound segment. So what we want to do is look at the PDU here, and so that's the last one. Once again, we're at the device here, and we want to see the outbound TCP port address. We could look at our layer port information underneath the out layers here, or you could look at the outbound PDU details tab and scroll down to the TCP section. And here for our outbound PDU, we have a source port of 80. We have a source port of 80. And our destination port is 1027. And destination port of 1027. Now, once again, this is coming out of the web server. So the source was port 80 because that's what the standard web server runs, is on layer 4 port 80. And so it's coming from there, and then it's going to port 1027. Well, port 1027 was what PC1, your web browser, way at the beginning of this conversation, that's what it assigned as its source port. Now it would travel through the network to the web server. Web server handled the HTTP request. Now we have an HTTP reply coming back. So those switched. Now we are destined for port 1027 on PC1. On to H. On both R2 and R4, run the following commands and match the IP addresses and ports recorded above to the correct line of output. So on R2, we run the show IP NAT translations command, and here we list all the translations we have. We can see that we have our inside global address, our inside local, our outside local, and our outside global addresses. Then we can see the requests that are happening. We can see what addresses they're using and also what ports they are using. Now, I might have more than you. You may have more than me. Okay, so this was R2. I'm going to minimize this. I'm going to go ahead and click on R4. Bring this up, make it a little bit wider. Click on the CLI, hit enter, type enable. Have to enter our password to Cisco or class. Sorry, it's password to class. Now we can go ahead and type in show IP NAT translations, and it'll list out the translations that R4 knows. So I'm going to position R4 over here. I'm going to slide my questions down a little. I'm going to bring up R2 here. Then we're question, what do the inside local IP addresses have in common? So what do the inside local IP addresses have in common? If we look here, the inside local IP addresses, well, these are all 10 dot numbers. If we look at R4, the inside local addresses are all 172.16 addresses. These are all private addresses, so that's what they have in common. These are all private IP addresses. Next question. Did any private addresses cross the internet? Now, did any of these private IP addresses cross the internet? What we have to look at is the outside local and the outside global. Is there any private IP addresses here on R4 on the outside local or the outside global? Nope, those are all public IP addresses. Here on R2, is there any private IP addresses on the outside local or outside global addresses? No, none of them did cross the internet. So our answer is no. On the step I, click the reset simulation button and remain in simulation mode. So they want us to reset the simulation. Now, to reset the simulation, right here behind my picture, kind of right above my shoulder, so you see my cursor go right behind my picture right here, there's a button that says reset simulation. So right here, you see where it says constant delay? To the left of that, there's a reset simulation button. Go ahead and click on that, and notice all of our PDUs went away, but still stay in simulation mode. Part 2, investigate NAT operation across the internet. So first part we did was going across the intranet. Right here is the intranet. Now here is the internet. We're going to go across there and we're going to see what the differences are. We're going to generate HTTP requests from any computer in the home office. Up here is our home office. That's the top network in our topology. Any PC, so we have a tablet, we have a laptop, we have a home desktop. We can use any one of those to generate an HTTP request. I'm going to go ahead, click on my home desktop, slide that up, click on the desktop tab here, make the window a little bit bigger so I can see the web browser app. Click on that, opens up our web browser. In here, put in a request for central server.pka and click go. So here, central server.pka and click go. Once you click go, go ahead and minimize the home desktop window. Just minimize, don't close it. If you close it, reopen it and put in central server.pka again and hit go, but just minimize it. Now we're going to click the capture forward button until the PDU is over the WRS. So right here, this is WRS, your wireless router inside of your house. I'm going to click the capture forward button. Right here is the capture forward button. Click it once. And once again, we're filtering for only HTTP output. You look here, that's what the filter is set for. Down here, kind of underneath the corner of my picture, it's set for only showing HTTP events. Probably have to do an ARP lookup or something, so that's why it didn't show when I clicked it once. I clicked it a second time. Notice our PDU now above the home desktop PC. I'm going to click it a second time, and it moves down to our WRS router. Record the inbound source and destination IP address and the outbound source and destination IP addresses. Let's go ahead and record those. We grab the last PDU right here. Once again, we can see at device WRS. We're on our wireless router. Go ahead and click that, opens it up. And then, whoops. And then we are looking for inbound source and destination IP address and the outbound source and destination addresses. Well, what we can do is look at when that PDU comes in, it's going up these layers here. And so this is the inbound. So our inbound source is 192.168.0.101. So here is inbound source of 192.168.0.101 and destination of, then right here is the destination IP address of our inbound packet, and that is 64.100.100.2. For the outbound packet, so outbound, our source is, now we switch over to this column. This is the outbound. Our source is 64.104.223.2. So our outbound source address is 64.104.223.2, and our destination is right here, 64.100.100.2. 64.100.100.2. I'm going to close the PDU information window on the step C. Oh, no, we got to answer the question. To what devices do these addresses belong to? Okay, so looking here. This IP address, 192.168.0.101, that would be the IP address of our home desktop. And so on the inbound, it is home PC, and then this address 64.100.100.2, well, that would be the address here. Well, let's go up into our address table. 64.100.100.2, that's an IP address here on R2. R2 is over here. Right? And so our answer here is, got to find where we are. It's for the inbound, it's the home PC and R2. And then for outbound, (64.104.223.2). Well, that's the IP address here of our WRS server. Or sorry, our WRS, our wireless router. If we scroll up here and look at our table, we can see that 64.104.223.2 was the address. So our source IP address is the WRS router, our wireless router, and then once again our destination is that same IP address, and that's R2. No, see how the destination never changed? But when we came in, it was the local IP address, a private IP address. Then it went through and did NAT and now the source is no longer the home PC, but now it's the IP address of our WRS router, so that way we can route traffic to and from it. Step C, click capture forward until the PDU is over R2. Record the source and IP destination addresses in the outbound packet. Now we have to move it to R2. I'm going to click the capture forward button. We're going to move this packet all the way down to R2. I'll click it once, goes to our modem, click it a second time, goes to the internet, click it a third time, comes out of the internet to R2. We are on R2 here. That's where we need to be. Record the source and destination IP address in the outbound packet. Now that the PDU is on R2, we can go ahead and click it, open it up, the PDU information window. And of the outbound packet, so I'm going to change to the outbound PDU, source and destination IP address. So right here we have our IP address information. Right here is the source IP address. So source is 64.104.223.2, and then our destination is 10.10.10.2. 10.10.10.2. Now, to what devices do these belong to? Well, the source belongs to, that was our WRS wireless router. So the source belongs to the WRS router. And then the destination, that belongs to, well, it's a 10 dot number, which is a private IP address. When we look here, where's the 10.10.10.2 address? Remember what we were doing? We were connecting to the central server web server. If we mouse over, if I click in the window, oops, I click in the window, mouse over our central server, we can see that the IP address of our central server is 10.10.10.2. And so that destination belongs to the central server. On R2, run the following command and match the IP addresses and ports recorded above to the correct line of output. So on R2, I'm going to close this PDU information window. I'm going to bring up the R2 CLI, hit there, hit enter a couple times to give me a clean working area, and then we type in show IP NAT translations. And we are looking for 64.104.223.2. 64.104.223.2 is our outside local, and then our inside local is 10.10.10.2. Notice the port is port 80 on it because we're going to the web server. Default is port 80, our layer 4 port number. And it came from port 1025. That was a randomly chosen layer 4 port number that the web browser used up here on your home desktop computer. I'm going to go ahead and minimize this. Now it says return to real-time mode. Back down here where it says simulation, just to the left of it, it says real-time. Go ahead and click on real-time so that way the background turns white. Your simulation pane went away. Did all the web pages appear in the browsers? Well, let's go ahead and go back to PC1. Yep, we did get a web page from the branch server. So we did get that. Click on the home desktop. We did get a web page from the central server. And so both of those web pages have displayed properly. Now, when we clicked into real-time mode, we didn't have to click that forward capture button. It completed the entire process for us. So yes, they did. On to part 3, conduct further investigations. Experiment with more packets, both HTTP and HTTPS. Answer the following questions. Do the NAT translation tables grow? Well, I'm going to look at R2 here. I'm going to repeat the show IP NAT translation command, up arrow, hit enter. This is what we have for our translations. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 translations happening. What I'm going to do is I'm going to go to R2 and then open up the web page for our branch server. I clicked on that. I click on our desktop tab, make it a little bit bigger right to left so I can see my web browser app. Click on that. And then I go ahead and put in branch server.pka. We now have branch server showing up. If we go back to R2, let's go ahead and repeat the show IP NAT translation command, up arrow, enter. We now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 translations. Okay, so when we did a request from a new PC, we got that. Let's go ahead and do changes to HTTPS. Now instead of requesting from port layer 4 port 40, we're going to request from layer 4 port 443. So I change that to HTTPS branch server.pka. I hit go. So what I'm going to do is I'm going to highlight some of the text in this page. I'm going to hit go. And then when the highlight goes away, that's because it loaded a new page. And I know we made that request and we successfully got that. I'm going to go ahead and minimize PC2, open up R2, and I'm going to repeat the show IP NAT translation command. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We now have 13 translations. So every time we start a new conversation, it's starting to grow. And down here on the bottom, we can see that this is now our HTTPS request. We are now looking at port 443, our secure web traffic, where everything prior to that was port 80. So do the NAT translation tables grow? Yes. There are additional entries as new conversations are started. Does WRS have a NAT pool of addresses? Does WRS have a NAT pool of addresses? Okay, let's go ahead and click on WRS. Opens up our configuration window. Go ahead and click on the GUI tab. This is our setup for our WRS, our wireless router. Right here we can see this is the IP address of our internal network. We can see here's our internet connection, automatic configuration of DHCP. Well, this home device is using network address translation, but it's using network address translation overload. Overload meaning we're going to do port address translation where we use one outside address to supply inside. And so WRS does not have a NAT pool of addresses because it only uses one IP address for every request of your internal devices. So no, it uses the same IP address for all devices. Next question. Is this how the computers in the classroom are connected to the internet? Assuming you're doing this in a classroom, or you could say in your house, is this how your network is set up? Well, the way to do that is to connect to multiple devices and see what the IP address reported from the outside is. So what is your global local address? Is it a public address or is it a private address? Is it the same address on all devices? Now, you could use a website to tell you what your IP address is. And so is this how the computers are set up in the classroom? Once again, we're looking at students in a classroom. Well, it depends. It depends on infrastructure. What you have to do is check what your outside reported IP address is. You could use a website called, okay, so http:// what is my IP.com. And then it'll tell you what is your IP address. What does it think your IP address is? You can go to another device, go to that same website. If you have the same addresses, that means you're sharing one address. If you have different addresses, that means you have a pool of addresses. Why does NAT use 4 columns of addresses and ports? I'm going to click back up on R2. Here's my R2, the show IP NAT translation. We have 4 columns. Besides listing the protocol, we have the inside global, inside local, outside local, and outside global. This is how NAT is translating your information. And so, why does NAT have it? Because it lists the inside global, you gotta spell inside local, outside local, and outside global addresses. Where are the networks outside global and inside global? So where are the networks outside global and inside global? You may have a packet tracer that has a wrong question in it. It should say outside global here. But where are the outside global addresses? Well, those outside global addresses, so outside global addresses they're from the WAN links. They're from the internet. Are from the WAN links to the internet. And then where are the inside local? So inside local addresses are from the LANs, the inside of your network, and so they're from the LANs. And final question: on which devices are NAT services operating? What do they have in common? I'm going to minimize R2 here. What devices are running NAT in our network? Well, we have R2 running NAT because we have a local network here. We have several local networks here. And then we have the public networks on the outside. R4, once again, has private addresses on one side, public addresses on the other. And then our home office has the same thing, where it gets one IP address from the internet. And then on the inside of the home network, we're running private IP addresses. So we have 3 devices, and those devices once again are WRS, R2, and R4. Now, what do they have in common? They all connect the local LANs to the outside networks, and those local LANs, they require routable IP addresses. And so connect LANs to the outside with routable IP addresses. That was Packet Tracer Labs 6.2.7, Investigate Network Address Translation Operation. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.